was the first step of rheumatoid pathogenesis. On the second step, we have to have a maturation of immune response. One or two molecules of citrullinate polypeptide won't trigger of such a disease. So we need epitope spreading. What is that? It refers to the development of immune response to endogenous epitopes resulting from release of self-antigens. The immune response to autoantigens may exist many years before disease onset and lay outside the joints. In this stage, epitope spreading and a gradually increased titer of anti-CCP can last several years before the onset of joint symptoms. We had one study where we had pooled serum stored, pooled serum of military personnel, stored for years, more than 20 years. And of those who developed rheumatoid later, it was seen, and also lupus, that these antibodies, rheumatoid factor, anti-CCP, are actually present years before, sometimes 10 years, sometimes 14 years, 15 years before the onset of the disease. So, low-level antibodies were present in all these years throughout the disease, but fulminant clinical rheumatoid was present at least 10 to 14 years after the presence of the antibodies. Actually, their blood was stored every year, so we could see the titer when it was first positive and then increasing titers, and it was seen that initially there were low level of anti-CCP and rheumatoid factors, and just before the clinical onset of rheumatoid, a few years before that, there was a sharp rise in the levels. And this is what we refer to maturation of immune response. Citrullination plays a unique role during osteoclast differentiation and anti-CCP induced osteoclast activation, which might explain important features of the gradual development of rheumatoid, including why the joint are targeted. We have the susceptible genes with epigenetic modification and post-translational modification, noxious agents, periodontitis and gut microbiome dietary factors, potential trigger site and environmental factors, which they are, induce the paired enzyme and production of citrullination, which is a neoantigen and triggers of the B cell to produce anti-CCP antibodies, and with the B cell help to the T cells and antigen presenting cells. We have the APCs, efficient APCs, to which the new antigen like citrullinated polypeptides are recognized as foreign, and also the B cells recognize them as foreign and produce anti-CCP antibody, and this goes on increasing in the maturation phase. And finally, we have antibodies and other cytokines. So the stage is set for fulminant rheumatoid. For a few minutes, we would keep pathogenesis of rheumatoid on bay and consider pathogenesis of all autoimmune diseases as a general. Now, in this slide, we would see that how a antigen presenting cell catches hold of a neoantigen. In our case, it could be citrullinated polypeptide, and this is a naive T cell. Naive T cell, how it is differentiated into T effector cells or sometimes as the Treg cells. Now, this is essentially all about what our body needs to do in case of bacterial infection, viral infection, or other mostly infections or infestations. The immune system was not created for autoimmune diseases. It was primarily created to protect us from various threats like bacteria, virus, etc. So we need this robust system intact to combat the bacteria, viruses, etc., fungus. But when the immune response has been mounted, most of the bacteria or virus have been killed or neutralized. We need somebody to tell the immune system that enough, come back to your own self, reduce the immune aggression, immune aggression actually doesn't only kill the bacteria or virus, there will be collateral damage. There are damage to the body also. So this would need to come back. And there plays the role of T regulator cells. Now, when the antigen presenting cell has presented an antigen to a naive T cell, it depends upon that cytokine milieu at that moment. In the presence of interleukin 12 and interleukin 2 in certain amounts, it would be differentiated into Th1 response. The Th1 cells predominantly would secrete interferon gamma and interleukin 6 and would act mostly against virus and bacteria. Now, if there is low level of interleukin 12 and low level of interleukin 2, it might differentiate it into Treg cells, where it is the regulator cell and it is the one which signals that you need to regulate your aggression and tone down the immune system and is responsible for immune suppression. In presence of interleukin 4 mostly, there is differentiation to Th2 type of cells, which gives immunity against parasites, but this Th2 response is also important in asthma and allergic reactions and also in certain diseases like lupus and Sjogren's. Th17 is the primary type which would protect us against the fungus, and Th17 is the primary type of response that is seen in psoriasis or ankylosing spondylitis. Now you would wonder, where is TNF alpha? TNF alpha would be secreted from this Th1 response, also Th17 response. So it is much downstream a molecule and it is a cytokine that is finally produced to increase the immune response. In this slide, we would see how the innate immune system and the adaptive immune system interact with each other and increases the immune response manifolds. Primarily, again I remind, primarily this is required to combat various bacteria and virus. This is primarily not meant for autoimmune or autoinflammatory diseases, but in these diseases also these interaction play a role. The dendritic cells are one of the most efficient antigen presenting cells. They get hold of the antigen and present it to either the T cells or the B cells. The T cells get differentiated to T effector cells and mount immune response, and the B cells produce antibodies. Again, they produce plasma cells where the antibody production is much increased, and then again interact with the natural killer cells, increase the natural killer cells, complements neutrophils, which are the ultimate effector cells and cause much damage, or monocyte or macrophage. So we see it is a two-way communication system, not a single one. Innate immune system is communicating with the adaptive immune system and vice versa, and increasing the immune response as time goes by. Though primarily meant for defense against bacteria and virus, in autoimmune disease this is the same way. So we have a genetic predisposition and epigenetic modification, environmental triggers, and this goes on inside the body, and small triggering increases the level of autoantibodies and increases the level of immune surveillance against that new antigen in the body.